Download this code from codegive.com, link in the description below. Fixed point decimal numbers. What are fixed point decimal numbers? Fixed point representation is a way of storing decimal numbers in a format that maintains a fixed number of digits after the decimal point. This is particularly useful in systems where precision is paramount, such as in financial calculations or embedded systems with limited resources. In fixed-point arithmetic, a number is represented as an integer that is scaled by a predetermined factor, often a power of 10 or 2. For example, if you want to represent 2 decimal places, you can multiply the value by 100 before storing it as an integer. Benefits of fixed-point representation. 1. Deterministic performance. Unlike floating-point arithmetic, fixed-point arithmetic provides predictable performance, which is important in real-time systems. 2. Reduced complexity. Fixed-point operations are generally simpler and faster than floating-point operations, making them more suitable for hardware implementations. 3. Memory efficiency. Fixed-point numbers can be stored in smaller data types, consuming less memory than floating-point numbers. Fixed-point arithmetic. Fixed-point arithmetic involves basic operations such as addition, subtraction, multiplication, and division. Here's how you can perform these operations. 1. Addition. Simply add the integer representations. 2. Subtraction. Subtract the integer representations. 3. Multiplication. Multiply the integer representations, then divide by the scaling factor to retain the fixed point format. 4. Division. Multiply the numerator by the scaling factor before dividing by the denominator to ensure precision. Example of fixed point arithmetic. Here's a Python example that demonstrates how to use fixed point arithmetic. In this example, we will represent decimal numbers with 2 decimal places. Python. Class fixed point. Def __init__, self, value, scale equals 100. Self.scale equals scale. Self.value equals int, value asterisk scale. Def __add__, self, other. If is instance, other, fixed point. Return fixed point, self.value plus other.value, /self.scale, self.scale. Return not implemented. Def __sub__, self, other. If is instance, other, fixed point. Return fixed point, self.value, other.value, /self.scale, self.scale. Return not implemented. Def __mul__, self, other. If is instance, other, fixed point. Return fixed point, self.value asterisk other.value, /self.scale asterisk self.scale, self.scale. Return not implemented. Def __trueative__, self, other. If is instance, other, fixed point. Return fixed point, self.value asterisk self.scale, /other.value, self.scale. Return not implemented. Def __str__, self. Return f self.value /self.scale.2f. Example usage. If __name __equals main __, a equals fixed point, 12.34. b equals fixed point, 56.78. Print, fa, a. Print, fb, b. c equals a plus b. Print, fa plus b, c. d equals a, b. Print, fa, b, d. equals a asterisk b. Print, f a asterisk b, e. F equals a slash b. Print, f a slash b, f. Explanation of the code. 1. Class definition. The fixed point class is defined to represent fixed point decimal numbers. 2. Initialization. The constructor takes a float value and a scale factor, default is 100 for 2 decimal places. 3. Arithmetic operations. Methods for addition, subtraction, multiplication, and division are implemented. Addition and subtraction. Simply add or subtract the integer values. Multiplication. Multiply the values, and then divide by the square of the scale to maintain precision. Division. Multiply the numerator by the scale before dividing to maintain precision. 4. String representation. The __str__ method is overridden to display the number in a readable decimal format. 5. Example usage. The script demonstrates creating fixed point numbers and performing arithmetic operations. Conclusion. Fixed point arithmetic is an efficient way to handle decimal numbers, especially in environments where performance and memory usage are critical. The provided example demonstrates the basic operations you can perform with fixed point numbers, allowing you to implement more complex systems as needed.